Hi everyone, Mr. Shields here with another way to determine which digits are significant. So if you remember from our previous lesson, the numbers 1 through 9 are always significant. I always consider them significant figures and I always count them. So the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9 always count. They're always significant. If I see an example like 785, I know that it has 3 significant figures because the 7, the 8, and the 5 all count, and I consider them all significant. So there's 1, 2, 3 significant figures. Now, zeros between significant digits are also always significant. So if you look at the 8 here and the 3 here, there are 3 zeros between them. They are always significant if they're between significant digits. Therefore, this number, 80,003, has 5 significant figures. If a number is out front, or a zero, I should say, is out front, like in the number 0.56 that I just typed here at the bottom of the screen. Zeros in the front are never significant, but zeros that are trailing at the end are sometimes significant, and that's where significant figures can kind of get tricky. It's when the zeros are at the end, and so let's talk about that right now. Trailing zeros in a number are significant only if the number contains a decimal point. So if you look here, right, 500.1, well, this one actually pertains to our previous rule. There's a 5 here and there's a 1 there, and the zeros are in between, so they're always significant. So there's 4 significant figures. The 5, the 2 zeros, and the 1 all count. But let's say I got rid of the 1. Well, if you look now, you look at the decimal point, and because there's a decimal point present, we know that these trailing zeros are significant, and that means that they do count. So in this example, they count. This has 3 significant figures. If you look at this number 500, the only difference in the example above it is that this 500 has no decimal point, whereas this one does. So these zeros are not significant because there's no decimal point present. So the only digit here that's significant is the 5. It's the only one we count, and there's only one significant figure here. So let's talk about the new example that I have, the new method that you can use in order to figure out which digits are significant, and it's called the Pacific Atlantic method. So if you look at a map of the United States, and here's New York, and Long Island would be located somewhere down here. You can barely even see it. If you think about the ocean that's located on this coast, on the East Coast, it's the Atlantic Ocean. That's the ocean that you swim in. And so we correlate the term Atlantic with the word absent. They both start with A. And if you go over here on the other side, California, Oregon, and Washington State, the ocean that they swim in is the Pacific here on the West Coast. And we correlate because they both start with P, the terms present and Pacific. And so the rule in our Atlantic Pacific method is that if there's a decimal point present, you start counting from the Pacific side, the left side of the number. And if there's not a decimal point present, you start counting from the right side of the number. So if I look at my example here and I'm going to add in a decimal point, I'm going to start counting from the left. And the rule is, using the Pacific Atlantic method, as soon as I count a number that is not a zero, I can count any number afterwards, including a zero. So here in this example, 5 is not a zero, so I can begin counting and I can count every number afterwards. So that's 1, 2, 3, 4, 5, 6 significant digits here. Let's take a look at that rule. If there's a decimal point present, start counting from the left side, present Pacific. And now over here, I look at this. Is there a decimal point present? No. So I'm going to count from the Atlantic side. I can only start counting when I reach a number that's not zero. So my first number here is 0. It does not count. My second number is 0. It does not count. And now I get to a 5. Now I can begin counting. So in this example, I would have 1 significant figure. And so let's take a look at some examples that I have up for you. This first example is obvious. The first example I look at, I think to myself, well, what's going on here? Are these zeros at the end? Are they trailing? And no, they're not. They're in the middle. And so I immediately know that they're significant. So we have 1, 2, 3, 4 significant figures here. That was easy. Now I take a look at my next one. I'm thinking Atlantic Pacific. Is the decimal point present or is it absent? The decimal point is, of course, absent. So I'm going to start counting from the Atlantic side. I can't count any digit until, or I can't count any zero, I should say, until I get to a number that's not zero. So I start from the Atlantic side. No, I can't count it because it's a zero. No, I can't count it because it's a zero. And there are is one significant figure here. Now I look at my next one. Is there a decimal point present? Yes. So which side do I count from? The left or the right? Well, where's the Pacific Ocean? Is it on the left side of the map or the right? It's on the left, so I start counting from the left. When I look, I can't start counting when I'm at a zero. So I cannot start counting. Now that I'm at a non-zero number, I begin 1, 2, 3. And so I have 3 significant figures there. Let's take a look over here. Decimal point present, which side do I count from? Present Pacific, I count from the left. 1, 2, 3. And of course, I can count this one as well. So I have 4 significant figures there. And lastly, is there a decimal point present? There is not. Which side do I count from? I'm going to count from the absent Atlantic side. I can't begin counting when I'm at a zero, so there is 1 significant figure here. And that is the Atlantic Pacific method. Hopefully you found it easy to use, and you might be more apt to using that method instead of our trailing zero method. They both will give you the exact same answers, but maybe this trick will be helpful. We'll talk about it in class tomorrow. I will see you soon. Bye.